Hello everyone. Today we're going to be learning some basic trigonometry. So I'm just going to start off with the right angle triangle. This square, by the way, denotes 90-degree angle, aka right angle triangle. I'm going to label the sides A, B, and C, and then their respective angles, big A, big B, and big C. Now that we have that established, I want to go explore our first identity, which is the Pythagorean theorem, which says a squared plus b squared is equal to c squared. Very important. All of trigonometry is based off pretty much this one identity. It is very important and it's not complicated at all, as you can see, but it only works for right angle triangles. So do keep that in mind. I'm going to give a practice problem here. I encourage you to pause and solve it on your own. Okay, I'm going to say this is 3 and this is 5. What is this angle over here? Well, so we know A, right, is 3 squared plus unknown squared is equal to 5 squared, which means that unknown squared is equal to 25 minus 9, which is 16. Therefore, unknown is equal to 4. Unknown cannot equal -4 because you cannot have negative side length. That doesn't make any sense, okay? Anyway, now that we've established all of that, it is time to move on to the trig identities. Okay? Trig ratios. And we're going to use the same triangle actually. So I'm going to denote, you know what, we can keep it as A. Okay. Sine of A. So locate your angle, right? Our angle is A. So I'm going to locate A over here. Now, I'm going to locate the respective angles. So the diagonal one, right, this one, is always going to be the hypotenuse, okay? So C is always our hypotenuse. Now, what is touching A? Is this one touching A or is this one touching A? This one, obviously, right? In other words, little a is going to be the opposite. Whatever the little letter is going to be the opposite. C will always be the hypotenuse. And then, like, B corresponds to B. You can see like that, right? So now that we've got that out of the way, sine A is going to be equal to the opposite, right, over the hypotenuse. So I'm going to draw a different triangle where I'm going to label it like this. And I'll say sine theta is equal to opposite over hypotenuse. Okay, next, cosine theta is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. Now let's go over cosine A. Ooh, what is cosine A? Okay, let's see. We want our adjacent, which is B, and we want our hypotenuse, C. Boom. Okay, now let's try and get sine of B. I encourage you guys to figure this one out by yourselves, but I'm going to go through it now. So we locate B over here, right? Our hypotenuse is still C. That's not going to change. However, we want our opposite, which is going to now be little b. So you can see sine A and sine B are different. They're not equivalent to each other. But basically with the sine ratio, it's just opposite over hypotenuse. That's what it's equivalent to. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You might also notice that, watch, if I do sine theta over cos theta, right, we'll get O over H over A over H. Our over H's can cancel out and we'll get O over A, which is the same thing as what? Look at that. In other words, sine theta is equal to tangent theta. Sine theta over cosine theta is equal to tangent theta. Right, now that we have established all of these. I'm going to just put this off to the side. Okay, now you might be thinking, well, this is only for right angle triangles. Like, what if I'm not given a right angle triangle? What is the point of this? Well, you're gonna see. We have two special identities left that work for all triangles. So I'm gonna do the same thing where I'm just gonna label this A, B, C. So this is C, B, A. Now, I want to use these identities that we just derived in this box over here. So I need a right angle triangle. What I'm going to do is split this. This is the altitude of the triangle, right? So I'm going to form two separate right angle triangles. So one is on this side and one is on this side. Okay? I'm going to label this side over here X, which would make this side over here A minus X, right? Because A is the entire length, and A minus this length X is just going to be the same thing as this length over here. And next I'm going to label the height H. Okay. Now using the Pythagorean theorem, which is the first thing that we sort of went over, we can rewrite c squared as A minus X quantity squared plus H squared, right? So that's this triangle over here. Okay, now I'm going to expand this as A squared, minus 2ax plus x squared plus h squared. The next thing I'm going to do is use the other triangle to define b squared. So b squared is going to be equal to x squared plus h squared. Again, all I'm using is Pythagorean theorem here. Watch this. We have x squared plus h squared right here. So we can just replace this with b squared because we figured out, right, that b squared is actually just equal to that. The next thing we can do is get rid of x because x is some unknown thing, right? We want this in terms of a, b, and c. So how can we rewrite x? Well, we can use our trig ratios. So you can see x is right over here in relation to this angle, right? If we take cosine of this angle, that's going to be equal to, right, adjacent over the hypotenuse, b. In other words, x is equal to b cosine c. And in that case, we can take what we had here and substitute that in. So we have c squared is equal to a squared plus b squared minus 2ab cosine c. This is cosine law. It's very, very similar to the Pythagorean theorem. It just has this extra part. You'll notice that when I put angle C is 90 degrees, right? Because in our original case over here, angle C is 90 degrees, right? What is cosine of 90 degrees? It is 0. So this whole thing would go to 0, and you would be left with the original Pythagorean theorem. Just another way of sort of verifying what we found. The next important one that I want to go over is sine law. So basically what sine law says is it relates sort of the ratio of angles and sides of their the sides and the ratio sine of the angle. So it says that A over sine A is equal to B over sine B is equal to C over sine C. Okay. Now, where would these sort of like be useful? Well, let's say you had the unknown side problem that we went over earlier with the Pythagorean theorem, right? And it's not a right angle triangle. Well, now you can use this formula. You do need to know the opposite angle. Okay. When I say opposite angle, I just mean if you can draw the angle like this and make like a straight line like that and it's diagonal, that's opposite. Same thing with sine law. These are all the opposite angles. Okay? Like for example, if I knew, I don't know, let's say this is 5 and this is 6 and I knew this angle was 20 degrees, then I could find this by using that. Or let's say I wanted to find the angle and I didn't know, and I just knew all the sides. Well, I can still use that. I can just rearrange this, right? We'll get a squared plus b squared minus c squared over 2ab is equal to cosine c. You may also see cosine law written like this if you're solving for the angle. So where would sine law be useful? Well, okay, let's say I knew this was 6, I didn't know this, I knew this was 5, and I knew this was 20 degrees. This corresponds to this corresponds to this. 5 over sine of 20 degrees is equal to 6 over sine of question mark. And then you can just isolate for question mark using basic algebra. And I did just realize I kind of forgot to explain the algebra part of this. Let's say I had sine theta is equal to 6, right? 6 degrees. Well, if I take arc sine on both sides, that will cancel this out. And we can say theta is equal to the arc sine of 6 degrees. Okay? Now, for arc sine, you would just put it in your calculator. Same thing with sine. With all of these ratios, you put them in your calculator. You can't really manually compute them. And this is like a fine final answer. Like arc sine of 6 degrees is fine. You can leave that. If it's like a common angle though, then I would simplify it. For example, arc sine of pi, or in other words, 180 degrees, is just 0. So I would just put 0. But I would encourage you guys to memorize sort of the angles, like the sine and cosines for the angles 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, 360 degrees, 270 degrees, and 0 degrees. Okay. And once you've done that, you can watch the next video.